If two portfolios have the same average return, which one is actually riskier? The answer depends on how the returns are distributed, not just where they average out. In this lesson, we will build the full toolkit: central tendency and location, dispersion, distribution shape, and correlation between two variables. For investment analysis, statistics turn a long list of returns into evidence you can interpret, compare, and use in portfolio decisions. The arithmetic mean is the sum of all observations divided by the number of observations. It is the most common measure of central tendency. Suppose three annual returns are 2%, 4%, and 6%. Add them to get 12, divide by 3, and the mean is 4%. The mean uses every observation, which is useful, but it also makes the mean sensitive to outliers. One extreme return can pull it sharply upward or downward. The median is the middle observation after sorting the data. With an even number of observations, average the two middle values. Unlike the median is not influenced much by extreme values. That makes it especially useful when the distribution is skewed. The mode is the most frequently observed value. A data set can be unimodal, bimodal, trimodal, or have no mode at all. Quantiles describe location by telling us the value at or below which a specified fraction of observations lies. Quartiles divide data into four parts. The first quartile is the 25th percentile, the median is the 50th, and the third quartile is the 75th. The interquartile range, or IQR, equals Q3 minus Q1. It measures the spread of the middle half of the observations. A box and whisker plot turns those ideas into a picture. The box shows the interquartile range, the line shows the median, and the whiskers show the extremes or fences. In the EAA Equity Index example, the first quartile is negative 0.293%, and the third quartile is 0.460%. Therefore, the IQR is 0.460 minus negative 0.293, which equals 0.753%. When an outlier is legitimate, do not delete it automatically. You can keep it, trim it, or Winsorize it, depending on the analytical purpose. A trimmed mean removes a stated percentage of the lowest and highest observations, then calculates the arithmetic mean of what remains. A Winsorized mean keeps the observations, but replaces extreme values with specified boundary values. It reduces outlier influence without discarding data. Central tendency describes reward or location. Dispersion describes variability around that center, which is why dispersion is central to understanding risk. The range is maximum value minus minimum value. It is easy to calculate, but it uses only two observations and is highly sensitive to outliers. Mean absolute deviation, or MAD, averages the absolute distance of every observation from the mean, so positive and negative deviations cannot cancel. For 5 returns with a mean of 16.4%, the absolute deviation summed to 50.98%. Divide by 5, and MAD is 10.2%. Variance solves the cancellation problem by squaring deviations. For a sample, divide the sum of squared deviations by n minus 1. Standard deviation is the positive square root of variance. Unlike variance, it is expressed in the same units as the original returns. On a BA2+, enter the observations in the data worksheet, review the one-variable statistics, and use SX for sample standard deviation. On an HP12C, calculate deviations carefully or use the statistics functions available in your setup. Standard deviation counts upside and downside variability. Target semi-deviation focuses only on returns below a specified target, making it a downside risk measure. For target semi-deviation, square only the deviations below the target, add them, divide by n-1, and take the square root. In the monthly portfolio example, a 3% target produces a target semi-deviation of 2.7634%. The coefficient of variation compares standard deviation with the mean. It measures risk per unit of average return and has no units. A higher CV means more dispersion per unit of reward. Be careful when the mean is negative because the usual interpretation of CV becomes meaningless. Mean and variance still do not tell the whole story. Shape measures reveal asymmetry and the likelihood of unusually large deviations. Positive skewness means frequent small losses and a few extreme gains. Negative skewness means frequent small gains and a few extreme losses. For a positively skewed unimodal distribution, mode is less than median, and median is less than mean. For negative skew, the order reverses. Kurtosis describes the combined weight of the tails relative to the rest of the distribution. It is about the frequency of extreme outcomes. Normal kurtosis is 3, so excess kurtosis is 0. Positive excess kurtosis indicates fat tails. Negative excess kurtosis indicates thin tails. The EAA daily return example has negative skewness and positive excess kurtosis, signaling extreme downside observations and fat tails. A scatter plot is the fastest visual check for how two variables move together. Tight clustering around a line suggests a stronger relationship. Covariance measures joint movement. It is positive when two variables tend to be above or below their means together, and negative when they move in opposite directions. Correlation standardizes covariance by dividing it by the product of the two standard deviations. It ranges from -1 to +1. A correlation near +1 indicates strong positive linear association. Near -1 indicates strong inverse association. 0 means no linear relationship. Correlation does not imply causation. Outliers can distort it, and spurious relationships can appear through chance or a third variable. Anscombe's quartet makes the warning memorable. 4 data sets can share the same means, standard deviations, and correlation while looking completely different. Exam tip: distinguish sample variance from population variance. Use n-1 for a sample. Remember that CV needs a meaningful positive mean, and never confuse correlation with causation. Remember 5 ideas. Mean and median describe center, quantiles describe location, standard deviation and downside deviation describe risk, skewness and kurtosis describe shape, and correlation describes linear co-movement. You now have the statistical foundation for interpreting returns and comparing investments. Keep practicing the formulas with real data sets, and in the next lesson, we will build on this toolkit.